Basic geometry. I mean, you're going to enjoy this, though, because this is basic, which means it's pretty easy. No, there will be no proofs.
Oh my God.
There will be no proofs. Ah, yeah, geometry has proofs. That's good. All right, so we're going to take a graph like this, and we're going to pick two nice points on this graph. So give me one good point.
0, 0.
How about not the origin, because that makes it a little too easy.
You said nice.
How about 2, 1? I just want the numbers to be different, so we have different numbers, 1 and 1.
3, 6.
Okay, how about -3, -6, just to be in a different quadrant. -3, -6. If you have 2 points, anytime you have 2 points, you have a straight line. That is correct. So what sort of things do you know about straight lines? They're straight. They have a slope. All right, so that's one of our things. If I connect these two dots, like so, I get a line. And whenever we have a line, one of the things we always talk about is the slope. All right, so how do you find slope of a line? It's the rise over the run. I heard that. That's correct. If you have 2 points, we usually use this little formula that I heard people say. That's correct. y2 minus y1 over x2 minus x1. All right, so plugging numbers in, what's the y2 number? -6 minus 1 over -3 minus 2. -6 minus 1 is -7. -3 minus 2 is -5. So our slope is 7/5. All right, so there's a little basic geometry. That's something you already knew. See, I told you this was going to be easy. All right.
Here comes the proofs, boys.
Oh, there's no proofs today. No proofs today.
Not today.
Not today. All right, so if I gave you 2 points, what else might you want to know about those 2 points? We might want to know the y-intercept of this line. That's true. Looks about -1. Of course, my scaling is
Yeah, your scaling's way off.
way off and pretty weak. So while it looks like -1, it might not be.
It just might be 0.5.
I wasn't really concerned about finding the y-intercept, but as long as you asked, how would we find the y-intercept?
Well,
Typically, we would use this nice equation. Y equals mx plus b. We know the m number. Okay, and then how would we find b? B would be when x is 0. But if I plug x equals 0 in, I get y equals b. That doesn't help.
I mean,
Plug in one of the other points.
2, 1.
2, 1. So I'm going to plug 1 in for y, 2 in for x, and then I can get the b all by itself. So 1 equals 14/5 plus b. I would subtract 14/5. I would think of 1 as being 5/5. 5/5 minus 14/5. -9/5. B is -9/5. Okay, so I was really only worried about the slope. But as long as you asked, we could find that y-intercept also. The equation of that line would be... We could find the x-intercept. In fact, we could find the x-intercept pretty easily now.
Yeah.
How would we find the x-intercept? Put a 0 in for y and get the x all by itself. So we could find that x-intercept too. In this section, we weren't really concerned about y-intercept. We weren't really concerned about x-intercept. But that's a good little review. We can do that. The other thing I was thinking of that we might want to know, I didn't really draw the whole line. I really just drew a line segment. Things we quite often want to know about a line segment is, how long is it? How far is it from there to there? Quarter mile. Maybe, depends on your scaling. So how do we find distance between 2 points? We use the Pythagorean theorem. What do you mean you use the Pythagorean theorem? All right, well, all lines are straight.
draw a triangle, right?
We draw lines that look like this and like that, and those have names. They're called
Sides.
vertical and
Horizontal.
horizontal. Okay, so what we're going to do is we're going to draw a triangle like so. We're going to make it a right triangle.
Make ourselves
And we're going to make ourselves a Pythagorean theorem. What's this point right here?
that. I don't know, it's 5 over.
How do you know it's 2, -6?
Yeah.
It's straight up and down from here, so it's got to have the same x number. And it's straight horizontal over here, so it's got to have the same y number. Okay, now we can find this distance. What's the distance from -3 to 2?
5.
5.
7.
And the distance from -6 to 1 is 7. So this is 5, this is 7. We can go talk to our buddy Pythagoras. The distance is the square root, so let's start it this way, I guess. If I call this distance, distance squared would be 5 squared plus 7 squared. So to find the distance, I would take the square root of both sides. Square root of 74. 5 squared is 25. 4 squared is, or 7 squared, I mean, it's 49. 25 and 49 gives 74. You take the square root of 74. Right, which apparently is a quarter mile.
It is a quarter.
Just over 8? Because 8 squared would be 64. So yes, between 8 and 9, definitely. All right, well, there's a different way to do it without drawing the picture. Well, you kind of do draw the picture. And then we're going to make a formula. So let's say I give you a point here, and I give you a point there. I'm going to call this point x1, y1. Actually, I'm going to change my mind. I'm going to call that one x2, y2. And I'm going to call this one x1, y1. I would do the exact same thing. I would make myself a nice right triangle. What would that point be right there? It would be x2, y1, because it's up and down from here, so it has the same x number as this one, which is x2, and it's left and right from there, so it has the same y number, which is y1. Now, how long is that side right there? You're right, it's y2 minus y1. Notice that's what happened here. 1 minus -6 gave us that distance. It gave us that distance of 7. This distance right here is y2 minus y1. Similarly, what's this distance here? x2 minus x1. Notice that worked here. 2 minus -3 gave us that 5. This is x2 minus x1. All right, so if I call the hypotenuse there d, how would I find the distance d? Close. Square on both, and then I have to square root the whole thing. The Pythagorean theorem would say d squared equals this distance squared, so that's x2 minus x1 squared, plus this distance, y2 minus y1 squared. So to get the d all by itself, square root it. So this is known as the distance formula. So the distance between 2 points is given by the square root of x2 minus x1 squared plus y2 minus y1 squared. So if you have any 2 points at all, you can find the distance using that distance formula. Questions on that? The distance formula is really what? Where did that come from? It's really a different way of writing the Pythagorean theorem. That's all it is. Distance formula is a fancy way of writing the Pythagorean theorem. Yeah, I suppose. First guy who figured it out, I guess. It was somewhat clever. What's that? The same guy who wrote the vertex formula? You think he did that one too?
Yeah.
Okay, so far we have two formulas. M is y2 minus y1 over x2 minus x1. And we have distance is square root of x2 minus x1 squared plus y2 minus y1 squared. All right, we're going to have a couple more formulas here in this section. Well, yeah, two's not enough. Somewhere between here and here, there's the halfway point. It looks like it's right about there.
Yeah.
Well, the distance from here to here would be the distance divided by 2. And the distance from here to here would be the distance divided by 2. But that doesn't really help me find the x value and the y value right there. So how do I find the x number and the y number for the midpoint? That's called the midpoint. Divide what by 2? Close. The x numbers are negative 3 and 2.
Yeah.
How do you find the value halfway between negative 3 and 2? Not negative 1, it's not 1.
Negative 0.5.
How'd you get negative 0.5? To find something halfway in between, don't you add them together and then divide by 2? That's called the average. You add them and then divide by how many there are. So if I want to find halfway between these two x's, I add the x's and divide by 2. How would I find halfway between these two y's? Same thing, add them and divide by 2. So that gives us another formula called midpoint. To find the midpoint, we do x1 plus x2, and we divide by 2. And then we do y1 plus y2 divided by 2. So that's the only one that has pluses in it. To find the midpoint means halfway in between. To find something halfway in between two things, you add and divide by 2. All right, the next thing that shows up in this formula, in this section, I'll leave some space because I'm going to write another formula here in a minute. We'll go back to this line that we had a minute ago. Oops, my scaling's even worse now than it was before. That's okay. We'll pretend it's good.
As long as you have the points.
Well, it kind of does, but we'll pretend it's good. We already found the slope of this thing, didn't we? The slope turned out to be 7/5. If I have a line, and the line is not horizontal, I'm guaranteed it's going to cross the x-axis, correct?
Yeah.
If it's horizontal, does it cross the x-axis?
No.
No, it could be like up here, and it would never cross the x-axis. It would cross the y. If it's vertical, will it cross the x-axis?
Yes.
Correct. A vertical line would come this way. So, unless it was on the y-axis and stuff. So, the point is, if I have a line, and the line is not horizontal, I'm guaranteed that it'll cross the axis, cross the x-axis. This angle right here is called alpha, and this is called, alpha is the angle of inclination. Inclination. I don't know if I spelled that right or not. That's right. How do we find that angle? We need to remember some trigonometry. We have not done any trigonometry this semester, but I know you did some trigonometry back in Math 1213. 1230. I had a free in it. Math 1230. What do you remember about angles? Sine, cosine, and tangent. That's correct. The one I want right now is tangent. What's tangent? Tangent of alpha would be opposite over adjacent. Opposite would be this, wouldn't it? And adjacent would be that. What's another name for opposite? It's going up and down. It's the y's, so it's the rise, isn't it? Up and down, that's the rise. And what's another name for adjacent? It's going left or right, so that's the run. So tangent of alpha is opposite over adjacent. It's also rise over run, which is another way of saying slope. Okay, so in this case, tangent of alpha would have to be 7/5. How do I get that alpha all by itself? What gets rid of a tangent? Well, it's not really tangent to the -1, although we use that symbol. It's really called inverse tangent, which is also known as arc tangent. And unfortunately, it looks like tangent raised to the -1 on your calculator. It's really not tangent raised to the -1, though. Tangent raised to the -1 is cotangent. So it looks like the right thing. All right, what I need to do is I need to make sure my calculator is in. We're going to use degrees in this section, actually. So I'm going to turn my calculator into degrees mode. And then I would do the arc tangent, 7/5. Alpha, in this case, is 54.46 degrees. All right, so there's our other formula for this section. Tangent of alpha is the same as the slope. Questions on that? Okay. No, that's all the formulas, I think. Pretty sure. That's 3,2. And this one looks like it's a -3, -3, comma, -3. Okay. There's one line. Yeah. Read that. That's a line segment at least. Here's another one. This one has, this point is, so it looks like it's -1,3. Okay, and this one looks like it's 2, -2. I don't think it's -7.
Yeah, it's around -7.
2, -7. Okay. 2, -7.
I mean, if you labeled your axes, yeah.
Okay, it'd be close. I can concede that. My question is, are those two lines parallel?
No.
They're definitely not parallel. We all agree they're definitely not parallel. How do we know they're not parallel?
Because they cross each other.
They cross. They're definitely not parallel. Are they perpendicular? They could be. The way I drew it, they look perpendicular. Depends on their slopes. All right. So how do you tell if two lines are perpendicular?
If they're slopes.
Close. Not just reciprocal. Notice, right. Notice this line definitely has a positive slope. And that one definitely has a negative slope. This one is pretty small because it's pretty flat. Where this one's pretty big because it's pretty steep. The rule is, two lines are perpendicular if, when you multiply the slopes together, you get an answer of -1. That's the same as saying the slope of the first one is -1 over the slope of the second one, which is the way you worded it. You said the slopes are negative reciprocals, which is fancy math word for flip it and slap a negative on it. Correct. That's what negative reciprocals mean. Flip it and slap a negative on it. Slap it good. Right. So, how are we going to tell if these are perpendicular? To figure out if these are perpendicular, we're going to find the slope of this line.
Yeah.
We're going to figure out the slope of that line.
Yeah.
And we'll see if they're negative reciprocals or not.
Yeah.
All right. So doing this line first, I'll call this one M1. The slope would be, subtract the y's, 2 minus -3, which is 2 plus 3, over 3 minus -3. So 2 minus -3 would be 5, not 6. And 3 minus -3 would be 6. So that one's 5/6. M2, on the other hand, is 3 minus -7 over -1 minus 2. That's 10 over -3. -10 Are those negative reciprocals? No. To be negative reciprocals, it would mean I take this one, I flip it over, whack it with a negative sign, and I get the same answer as I got down here. Did that happen? No. So are these parallel? No, definitely not. Are they perpendicular?
They're close.
They're close, but they're not. So not perpendicular. How would you know if they're parallel?
They would not touch each other. Or they would.
The slopes would have to be exactly the same, but the y-intercepts would have to be different. That's correct. That's how you would know they're parallel.
Look at the snow.
It is snowing.
Look at that.
Welcome to November.
Very first day.
Oh, I just filled it.
Just quit. I'm not even right now, boys. I'm just.
Every now and then you might area, and you'll see a yellow sign. They're yellow. And it'll say, trucks use caution, 8% grade.
Yeah.
Usually it means the trucks need to go into a low gear. They use the engine to hold them back because they'll carry so much weight, they'll wear out their brakes if they try to just use their brakes.
Yeah.
Right, if they got a gear down, the engine holds them back, they drive real slow.
That means it has an 8% slope.
What do you mean by 8% slope?
This is like 8%.
Well, what it really means is it's not an 8% slope. Slope is just a number. Slope doesn't have a percent. What it really means is the hill has an angle of inclination of 8 degrees.
Yes, around 27. We have around 27. It's around
8 degrees is around 27 degrees?
27.
Anyway, if the angle is 8 degrees, then what is the slope? Something.
It's the tangent, inverse tangent.
We just had a little fact that said tangent of theta equals the slope.
Yeah.
It is alpha, and I wrote alpha, and I said theta.
Wow.
Things just come out of my mouth sometimes. So slope would be the tangent of 8 degrees. We would grab our calculators. Tangent of 8. Which means the slope is 0.14, or you could write it at approximately, or it's about 14 over 100. Which means if you have an 8 degree slope, At 8-degree angle, your slope is about 14 over 100. So every time you go 100 feet across, you go about 14 feet up. Depends on which way you're going, if you're going this way or that way. Correct. All right, questions on anything?